we have dubbed our little project here Wet Sound. It probably isn't appropriate, but that's what we're calling it. So we have a file that says that, and we stuff everything in it on our computers. So I'm going to go through this slideshow, and we've got a few pictures and a few things to talk about if I figure out how to do this. Okay. What we think we don't know about sound in water. And I used to refer to these kind of things as unkunks, unknown unknowns. And the more Jim and I get involved with the analysis of the underwater soundscape, particularly how with marine mammals in it, the more we realize we're just scratching the surface. And we hope to show you some of these things that we're doing today. So I started in the Amazon, actually doing recording marine mammals back in 2007. My wife is a marine biologist and also did a lot of outreach program for education and medical outreach in the Amazon, and I was the bag carrier, but I kept seeing these dolphins in the river called pink river dolphins, or for the scientist here, ETA geoforensis. And I had done work with marine mammals over the years and said, well, you know, we can voice print these guys and count them, because I discovered by looking on the internet that nobody knew how many of them there were. And at least in Brazil, they're considered to be either endangered or at least a threatened species, because they're taken for bait and stuff down there. So that's how I got started. We have lived on a farm since 1977 between Silverdale and Poulsbo. We did look at a house over here, but back in the days we came in 1977, we couldn't afford one. But I wish we'd have bought it then, because it was retired from the Navy, was majored in chemistry, and did work in nuclear physics, and did a lot of work in and after the U.S. Navy, my career there in underwater acoustics. So anyway, I thought this would be an appropriate introduction. As most of you know, 70% of the Earth is underwater. And what's going on in my mind is that over the last decade, the technologies that have become affordable and available to anybody, whether you're a scientist or a citizen scientist or just a hobbyist, it's amazing how they've given power to people to do studies like we're doing that 10 years ago you just couldn't do. And so that's how well, actually it's 15 years ago now, that's when I started. So the technology-driven things got me involved with these dolphins, and this is what they look like. These animals, they have found fossils that are 25 million years old. They're one of the two oldest species of toothed whales, or in case dolphins, Odontoceti is the technical name, that exist. And the sounds that they make, as you'll see here in a second, just think about it. Best I can determine is paleontologists and anthropologists believe that humans didn't really have used speech earlier than 500,000 years ago. So these guys have been around a lot of time to develop their speech. This is the system I took down the first year. It fit in my shirt pocket, and but it was affordable. This was a underwater microphone called the hydrophone that we took down, built by a guy over in Seattle. It was affordable, but kind of the most expensive thing that I had on that trip. We chartered a boat, looked on the internet and found a guy that built this boat with a lot of battery capacity, because his his mission in life was to catch a thing called peacock bass, which are in the upper Amazon of Peru where we go. This boat was in Peru. And they're very spooky fish, but they're prized by anglers worldwide that come down to the Amazon to get their trophy. So Bill Grimes, the guy that built the boat, or had the boat built, set it up to where it could run for 3 days without any rotating or noise-making equipment on board. And they could sneak into these areas, and of course it fit what I wanted to do, which is to record dolphins without a lot of interference from machinery noise. We took the boat up into a very pristine, remote area of the upper Amazon on a river called the Ucayali River, and into a preserve that even indigenous people don't live in because it's flooded year-round. But it's full of dolphins. And that was the first year that we did that, and have done it many years after, annually afterwards. This was our laboratory where we analyzed the noise of the dolphins. The gal on the right, Shirley Sherman, is a Bainbridge Islander. My wife Dottie, myself, and the gal that is the wife of the owner of the boat. And the way we were able to start analyzing this was with a free program on the internet called Audacity. Some of you may use that for other things, but Audacity allows you to, after you record with the microphone these animals, you can start analyzing the details of their sound. And what I want to do is actually show you, and I'm going to have to go out of this slideshow, but I've set up my Audacity to play what I heard on one of these recordings that we made up in the Pacaya Samaria wilderness area. And so at the time, I had no idea what we were recording, but when we got back and we started using Audacity, this is what I heard. In fact, this is what I heard on the headset as we were recording. So this is time is going horizontal and amplitude is going vertical. And this is just a voltage out of that hydrophone that we have that converts sound energy in the water to electrical energy that we can sense and record and put into a digital storage. So really it's not very impressive. And I'm looking at these pretty large amplitude things, and I didn't really understand what I was looking at. So what I'm going to do is stop this, and I'm going to put my, go ahead. I'm going to put my glasses on so I can see, and we're going to, oh, that was a catfish, that wasn't a dolphin. So I took one of these little hunks of higher amplitude stuff, and I can zoom in on that little chunk. And when I do that, I see this. And then I can actually play this back at a reduced speed. And when I do that, if I can find there it is. I'm just going to play this back. This is what that little bump was. And this is what it sounds like, slowed down by 90%. So that told me two things. It told me, yeah, there's something going on, even though I can't hear it, which means it's above the threshold for human hearing, which is about 10 kilohertz. And my recordings were just rich with this stuff. Well, as we were doing this particular recording, and this was the first place we saw this, we got into much louder amplitude sounds, and right here's a good example. And when I played that at regular speed, Dottie was keeping logs, and I said, well, this sounds like popcorn popping. So we dubbed it popcorn. So then what I decided to do is okay, let's slow this down and see what it sounds like. And when you do that, almost sounds like a shotgun going off. And what we were observing at the same time, a group of 3 adult pink dolphins feeding at the shore of the little lake that we happen to be in off the Amazon. And we think that what they're doing there is either stunning or disorienting the fish so they're easier to catch and eat. And when I got back, I talked to a couple of professors that made their life history studying this stuff. And they basically, the guru of the world in that area was a fellow from the University of Hawaii by the name of Winthrop Owl. And he told me, no, that's not possible. Well, within a couple of years, other people adopting this technology, they're saying, hey, we're seeing this with bottlenose dolphins, we're seeing it all over the place. And so he finally came around and did a paper on it. And sure enough, we think that's what they do. So I'll get out of Audacity and go back to my PowerPoint slides. And I decided one of the things I did find out is that the clicks that you heard, the equipment that I had with Audacity and the range of sampling that I could do, the clicks were above that, extended above where I could actually analyze them. So I found a piece of software called Raven from the Cornell lab that does a lot of bird sound work, and acquired that and started really looking at this stuff in more detail. And over a couple of years, we were able to identify these clicks, and each one of these is like that click that you heard, but extended up, in this case, to about 250 kilohertz. It even goes higher than that, but for sake here, that's what we're looking at. You'll notice that there are red areas in the clicks. And we processed these clicks with a team that had formed with us that was pretty much globally located, and a fellow from the University of Toulon in France, a guy by the name of Professor Harry Gloton, had been working, he's a physicist, he was working on what they called deep learning at the time, now it's AI. And he had access to the CERN computers, which is a big physics laboratory in I think it's in Italy and Switzerland, that have enough power in the computers to process this way more than we could. But what happened was that, let me back up a second. If you go to the internet and you go to Facebook, you go to just type in Google looking for the sound on metal plate. That's all you have to put in there. And you can hear the dynamical thing of this. But this is an example of what we think is happening with those clicks. If you make a 1,000 cycle per second tone on a metal plate, that's the pattern you get. When you go to 3,000 cycles or 3 kilohertz, it changes. And it actually changes at 1.01 kilohertz, it changes. And so the hypothesis is that these animals use their clicks not just to find prey and be like a sonar, but they use it as a communications medium with huge bandwidth compared to humans. Our aural bandwidth is about 10 kilohertz. These guys go to at least 300 or 400 kilohertz. So there's orders of magnitude more information potential in those clicks than there are in what we can hear. We use sight more than we use hearing. Okay, I'll get back on track. Well, this led to the first published paper that we did on these clicks. And we presented that paper in, I think, 2014 or 15. And now I'm going to turn it over to Jim Henderson. He can tell you what he's been up to.
Okay, well, my name's Jim Henderson, and I have been involved in oceanography and underwater acoustics for just a lot of years. I started, interestingly enough, out of college as an Air Force pilot. And I flew for 5 years, and I traded the air for the ocean. Went back to graduate school, and I've just been having an absolute ball exploring on doing really interesting things in all the world's oceans. So, okay, Dave? And so Dave was in the Amazon. Let's get a little closer to home. And this is an area called, outlined in red there, it's called the Salish Sea. And Puget Sound is down in the bottom of that, and, okay. And Salish Sea has a number of different marine mammals that are endemic to this area. And across the top there you can see minke, gray, and humpback whales. And also on there are orcas and Pacific white-side dolphins and harbor and Dall's porpoises. And interestingly enough, each of these species makes noise that you can hear underwater. And each of those are different, okay? And so let's get a little closer to home. And Dave and I had the opportunity last summer to go out and actually make some measurements. And we were on a vessel called the My Shannon. And right over here are Joe and Shannon, who had the vessel. And they were kind enough to take us around. And here you see those two up in the wheelhouse. And then on the right there, Dave and I are just doing a little data analysis on some of the things that we had been recording. Okay?
Now, I want to interject something. He's Air Force, I'm Navy. We don't always get along. And I'm sure that
he moves too slowly.
Okay, go ahead, Joe. Whoops.
Okay, and so what we did off the vessel, the My Shannon, is we constructed what's called a hydrophone array. Okay, and this is those black things sticking out at each thing. There's two at the bottom on each side, two coming up, and then one there. Those are the hydrophones, and we had them in a configuration as to where once we put those over, and there's cable going up to the surface to the laptop, and we could make recordings from there. And I'm in the process just of putting this over the side on an absolutely beautiful day. Okay, Dave. And this is an example of some of the things that you can hear within the Salish Sea, Puget Sound. And off the top here is what Dave has shown in the past is what's called the time series. Okay, and in this time series, the vertical axis is time, and going across the bottom, or the vertical axis is level, and going across the bottom is time. And then in the bottom one, we have what's called a spectrogram. Okay, and we have frequency going up and time going across, and what Dave was just playing right there, you can hear the whistles, the sounds. That's what it sounds like, and that happens to be a humpback whale.
These carry for miles.
Okay.
The next one.
Okay. This is again a time series across the top, yet this is an orca. And so go ahead, David. Hear that whistle? That's something you may have heard. That's the whistle of an orca, and then also embedded in there are clicks. The whistles are of a lower frequency. The clicks start about 4 to 8 kilohertz and go much higher than that. So this is the kind of things, if orcas were in the vicinity like they were just earlier this week around Bainbridge Island, you would expect if you had a hydrophone in the water to be hearing something like that. Okay, Dave?
And one of the things we should point out is there are actually about 4 or 5 animals in this short little segment of recording. And each of them have unique socialization calls, which is what you see on the red area of the spectrogram. And nowadays they're using AI to start identifying individuals around the world by these calls. And there's a lab up in Canada called Orca Lab, and they've done some of the groundwork on that, and we work with their data. And so you can not only spot these guys and look at their fin shape and their colors, but now from their acoustic sounds, they can identify that's J23, a female, 22 years old, she has 4 calves, that kind of stuff. So the technology is really moving.
Okay, and this is an example of what it looked like in the main salon of the boat, in that this fellow here on the left, that's Hervé Gulton that Dave mentioned earlier. On the right there's some black boxes, if you will, with a bunch of wires coming in and out of them. And that's where those wires that came from the hydrophone up onto the deck and into that box. And Hervé's actually he's done some recordings and he's doing a little bit of analysis here. Now, we have worked with Hervé, and what he does is he goes around the world and collects information, collects recordings from marine mammals. He sends them to us and he says, would you guys take a look at this? Tell me what you think's going on here, or look at what's happening here. And so we go using some very sophisticated tools that we've put together and do analysis of the things that he's sending to us. And then Dave in the center there is fulfilling a really important role in that he is looking at something called Orca Watch?
Yeah.
Orca Watch, which identifies where the orcas are in Puget Sound. And so he's saying, oh guys, we need to leave here and go over there. Maybe we can get to a point where we can stop and make some recordings. The guy in the background with the sunglasses, that's me. I'm making lunch. Okay. And then this is a series of clicks that we've been talking about from orcas. Okay, and you can see across the top, there's that time series that you're seeing again, and you see this big up and down, and then it gets quiet, up and down, and we have seen clicks that the spacing between there has been like a half a second, or maybe a third of a second, all the way up to essentially thousandths of a second, depending on what the species is. So some of these things are clicking really fast. Okay, and then on the bottom there is what we call the spectrogram. And you can see the different colors there. And those colors, as it goes up, that's higher in frequency, and the colors are actually the magnitude of the intensity of the call at that time, or the click at that time. And what you see is that those bright spots, those red rays change from click to click to click. And we have taken a very careful look at that in a number of different species, and we are of the opinion that could be communication. Not only is it clicks that are going out and identifying a salmon or something like that, I want to go eat that, but also because these things change so rapidly that could be communication between animals. Okay?
Yeah, I'd like, for those of you who may have some technical, that click lasts about 30 microseconds. It's not a very long click in terms of the actual energy from the animal. We sample, in this case, at 500,000 samples per second, feed into our computer. And each sample is a 24-bit word that allows us to create a file called a WAV file that gives you these recordings. And so one of the challenges is we have to use a lot of memory. And think back 10, 15 years, a gigabyte, we didn't even know what a gigabyte was. It was so big. Well, now we're dealing in terabytes that we can afford. You can go to Costco and get a 5 terabyte traveling hard drive. And that's 10 to the 12 bytes. So we're able to, we're able to do these things that we couldn't do 10, 15 years ago. Go ahead, Jim.
And we should point out that Dave has mentioned a software program called Audacity and something by Raven. We're using something called MATLAB, and we're using a series of applications which were developed by a rocket scientist.
Truly.
Truly. This guy's a rocket scientist at NASA. And we found that, and we took a look at it and said, I wonder if we could use this and do some of the analysis that we want to do. And it's because of the tools that he developed to analyze rockets and all the things that they were doing with rockets, we have been able to come in and do some really sophisticated things and see things that nobody's ever really seen before. And this is just a quick example of something that we look at. And you can see the little spikes along the left-hand axis there, and spikes. Those are the vocalizations. And then as you move up, you can see these white things going across. Those are clicks. And then you can see white and then some yellow going up, and those are higher amplitude clicks that are coming in, and then some more white and some more, and then some more vocalizations and such. And what we do is we zoom in on one of those clicks, and then we start to look at that in a lot of detail, and we can determine some really interesting things, and we can watch those frequencies change between the clicks. And that's was really our first clue to think that, gosh, there could really be some communications in here. Okay, Dave? And I will hand it back to David.
Okay, Jim didn't want this slide because he says it's too busy, and the only reason I put it up here is this is the slide on the left. That goes up to about 10, 15 kilohertz in frequency. All of the world's governments use that particular slide, it's called the WINS curves, to set rules on shipborne activity around marine mammals. On the right's just a simple, comic book thing of you got ships making noise and animals making noise, and they mix up. So I like that. There's a term called acoustic gaze that's become adopted by people that worry about marine mammals, particularly, or the sounds in the ocean. And marine mammals have this acoustic gaze. They don't, half their life is spent in dark, so they can't see like we can. But they've evolved acoustical analogs to our visual ways of sensing our environment. And what I use here is, consider a big end city. You got 10 kilometers. When it's a clear day, you can see. At 5 kilometers as the fog bank moves in, and it gets thicker to 2 kilometers, and pretty soon it's down to where you can't see your hood ornament. And it's the kind of thing that we have been reporting on as far as the impact of anthropogenic noise, which is a fancy word for human noise, mostly from marine vessels, impacting these marine mammals. And so they're blind if there's a ship that's making too much noise or too close to them. And here's one of the breakthroughs. We did a study for Hervey to give a talk to a bunch of politicians and admirals and people that are decision makers in the Mediterranean. And this particular encounter is with a cruise ship. And I'll let you listen to what they hear, the marine mammals hear. I hope I can let you listen to it. There we go. So he's about 3 to 5 kilometers away there. Whoops, that's the middle one. What you're hearing there are diesels. Let me go back again. I'm going to stop this. This is when he came into Johnstone Straits. That buzzing noise is part of the ship. And then when you get up here, when he gets close to these, you can see the dolphins or the orcas around him, this is what you hear. Hear it drop off? The sound drops off substantially. The reason is the captain of the ship stopped the propulsors so that the passengers could look at these orcas. And in analyzing this is from Orca Lab that we've worked with. The ship was doing nothing that was considered to be illegal as far as approaching and being around marine mammals, as the current rules exist. But the rules are in the process and have been modified since then. Okay, so I'm done with that one. Whoops, what am I doing here, Jim? Okay, so that ship is the Norwegian Jewel. It's a pretty typical cruise ship that goes up and down the inside passage to Alaska all summer. These ships are all over the world. And what Jim and I saw was that the acoustic signature from this ship didn't look like any ship that I was used to. I was a submariner for a good part of my life, and I thought I knew something about ship propulsions because we used to detect the bad guys that way. But this was totally different. And even though he was following all the rules, the sounds that he was making were not like sounds that the rules were made to determine how close people could get to orcas or any other marine mammal. And this is this is off of the Mat Lab, and this really was sort of the thing that showed us what was going on. The oldest information is at the bottom, and the newest information is at the top. It's a waterfall display, is what we call it. So these lines are lines from these things. They're called azipods, or azimuth propulsors. Each one of those weighs 250 tons. There are 2 diesels attached to each of those in the ship that run at a constant 500 RPM. They're 12 cylinder large big diesels. And they deliver DC power to these pods that rotate 360 degrees at 15 degrees a second. A second. And that's what pushes or pulls the ship through the water. They're very efficient. They allow the ship's captain to go into ports without using tugboats. But the real problem is the sounds that you saw there that were right, and I'll go back to this. You can see we've labeled, it's when that's all running, you're wiping out the clicks from the orcas, and also you're wiping out the vocalizations. So they're basically blinded while that ship's around. So these azipods they're DC motors, so they have magnets. They have a stator that's a series of magnets along the pod, and then they have a rotor inside that's also a magnet. And we believe that the noise that they're making is the magnetic field collapsing and expanding as the motor rotates. That's what makes it rotate. And it does it at the frequencies, unfortunately, where marine mammals use their acoustic gaze to do whatever it is they want to do, communicate and or find prey and or navigate. So we reported that in a symposium in France. And as a result of those findings, and others, obviously we're not the only ones working on it, they've changed the rules. All of the big ferries in the Mediterranean and in the Atlantic use these same propulsors. Some of them one propulsor can generate 24 megawatts of power. So it's a lot of energy going into the water. And they've actually changed the rules now as a result of this, realizing that these new technology ways of moving ships, container ships, all of them use this. If they're built after 2005, we have to pay attention to it. Okay.
Okay, again, closer to home here. Orcas in Puget Sound, and I'm sure most of you saw the little show that went on at the beginning where it showed the orcas in different areas as they moved through last week. Okay, and there's the resident community. They typically mostly eat fish. As Dave said, they may have been changing their diet a little bit, but right now those orcas are considered endangered within Puget Sound. There's also what Dave mentioned is the transient orcas, and these are transient. They come from the northern part of Salish Sea. They may come from out in the ocean. They periodically go through Puget Sound, and they like to eat seals. And they take care of any of the seal population. And it's interesting, as they're moving through, they don't click a lot, nor do they make a lot of noise, because they don't want to scare the seals away. So they'll come across these seals and snatch them.
And you'll see seals up on buoys, and probably on your if you have a dock, if you see seals on your dock, it probably means these guys are close. So.
Yeah. And like the transients that come through, the seals, smaller marine mammals, they also eat seabirds if there's a seabird sitting on the surface. Okay, Dave. Now, the state of Washington and British Columbia, Canada have developed a number of regulations, rules and regulations that they've put in place to protect these marine mammals. And essentially what this is saying is that there's U.S. and Canada mixed there together. Canada's in meters, we're in yards or feet, and they're saying that a vessel speed of no higher than a half a mile of an orca, 7 knots. Okay, keep the speed down if you're close to them. And the distance from an orca is 300 yards from either side, 400 yards from behind, or 400 yards in the path of the orca. And they've set these up, and one of the issues is it's been difficult to get this information out to the marine community. They haven't really figured out how to do this, and unfortunately, what we have here is 2 orcas down in South Sound, 4 kids on a jet ski. Notice no life jackets on them. And they were trying to get up to those orcas to touch one of either touch the orca or touch whatever it might be, okay? So obviously, they didn't get the word. Who really didn't get the word was their parents, i.e. life jackets and stay away from these animals. And this is...
We actually have videos of this, but Shannon, my daughter, took the videos, and she used some words that would be inappropriate.
David. So we have this, and this is not an isolated incident, and you'll probably notice that you'll hear from time to time one of a group that's down in Olympia continues to promulgate these regulations as they learn more about it. Okay? Now, this is some things that you're not going to see anyplace else or hear about. We have been a part of Hervé, which we talked about earlier, goes around the world and films and takes the recordings of underwater of these marine mammals. Okay, and the first thing we're going to look at is an orca herring ball. Orca herring ball, and the orcas are circling. There's one right there. And you can see it kind of coming around. It's hard to see. There's another one right there. They're circling this prey, okay? And they're getting them into that school like that. We also know that humpback whales will put out a bubble screen. And they'll do exactly the same thing, circling in, and then they'll go through and feed like the orcas will go through and feed, okay? But something that nobody's ever seen before. There's another orca doing this, okay, and kind of get ready for this. There's a humpback whale that just went right through that school of fish.
You didn't have to blow bubbles.
Okay, look at that baleen, absolutely full of fish. We have not only we have, and you're going to see here in a minute the guys in the water taking pictures of this stuff. Okay, and then again, here comes another orca up through, and there's a calf right behind her. Okay. What's really interesting about this is that the acoustic recordings that were being made during that time, we think that we might be seeing communication between the orcas and the humpbacks. Nobody has ever seen anything like that before. And we think we got it. The Norwegian team is going up there again this year, late summer, and we're going to get better recordings and hopefully at least as good videos so we can actually start to nail down if there is actually communication going on between those two species. That would be really something.
This was taken with a GoPro. It was underwater proof. So the sound isn't anywhere near what we need to do the analysis. And unfortunately, they didn't have a time sync so we could match up what we're hearing. But we actually found low frequency clicks from these, we believe, from these humpbacks. So.
Okay, and the next one we're going to look at was taken up out of Orca Lab in Johnstone Strait. And this is an interaction between an orca and Pacific white-side dolphins. So you can see these guys, they're cavorting around these whales, around the orcas, the Pacific whitesides. And everybody thought, oh yeah, we've seen this before. They're using eyesight to assure that they don't run into them. In the recordings that were made up there at extremely high frequencies, we've discovered that those Pacific whitesides are putting out clicks that start at 120 kilohertz, okay, and are milliseconds apart. They're differentiating something that's that big, and they're swimming it. So they're not only using eyesight, but they're also using acoustics to ensure that they don't run into that whale. And that's another thing that nobody had ever seen before, and that we're in the process right now of working with the French group to write a paper on that.
Jim is an Air Force pilot, and you flew with the Navy, and we have thought, you don't want to run two airplanes together. These guys are weighed as much as some of the airplanes you flew. And so how do they keep apart, even though they're weaving in and out of each other? Well, we think this communication and some basic sonar is how they do that. And it's, again, the technology allows us to see things you couldn't see 10 years ago.
Okay, so here's Bainbridge Island, the area around it.
63 miles.
Okay, and as Doug said earlier, we did some projects here at the barn, and he asked, hey, can you guys think about doing something else? And Dave and I kicked a few ideas around, and we are in the process right now of developing a prototype for an acoustic measurement acquisition system that people can build in a series of steps here in the barn, and that system is going to be deployable off the side of your boat, toss it over, or potentially hook it up to a dock, or even moor it out in front of your house. And what we're going to do is, we're not going to have a cable running up to the beach or back to the boat. We're going to Wi-Fi this signal back. So if you're in your boat, you can be sitting in your cabin or wherever with your laptop and getting the information. You'll be able to hear it, but if you hear something really interesting, you push a button, you'll be recording it. And then you're going to come back and be able to take those recordings and look at some of this software and do some analysis on it yourself. And we're working with some people in the barn right now. There's a possibility that we might put a server here or somewhere that would take all the information that these people are gathering, put it and make it available to everybody.
Okay, are we done?
Questions?
Great.
So, any? Yes, sir.
Those cruise ships with the big amphipods, what are some of the rules or regulations they have to follow now just to slow down and avoid those areas, or they have to be known in advance there's whales in the area, I would think, right?
The one that I pictured was within the rules. He has to slow down below 7 knots if he detects or knows he's in waters frequented by marine mammals. But again, as I pointed out, those rules were written based on those decades-old winds curves, and don't account for the azopod, the new propulsors, and the kind of sound that they make. So, at least in the Med, they've started changing those rules to not even allow ships in certain areas where there are marine mammals that either are going to be sensitive to the sounds. And the Canadians, I know, are far more aggressive in doing this than we are. So I don't know what it'll end up being. There's a lot of politics. I mean, like the rules for staying 300 feet away from orca. Well, if you're in your motorboat fishing and an orca comes up to your boat, are you violating somebody's rule? Well, the common sense thing is just turn your motor off, because the sound is what the offensive part of the engagement is.
So you have evidence of motor noise interfering with orca noise, and you have videos of the orcas. Do you have proof of behavioral changes when the mass like that? Are they bumping anything?
Yeah, essentially the question was, do we have information on potential impacts of what the noise is doing to these animals? And the answer to that is yes, we do.
Right here is one.
We have seen that in a change in orca behavior as these cruise ships were going through up in Johnstone Strait. As a for instance, the mothers quit nursing the calves while this was happening. And that's just one of the things that people have observed. So there are impacts. And we've seen changes in behavior that they were kind of schooled together and then they just kind of split apart. We also, when we were out earlier in the summer last year, or late in the summer last year, we saw as the pod was headed north in South Puget Sound, we saw the males come over to one side where some vessels were, and we just happened to be sitting. We weren't moving, everything was shut down. We were just sitting there. They came over here and started leaping and doing all kinds of things. It was like to attract attention to the boats, yet over on the other side of the sound, the mother and a calf were going up the other side. So it's like they were trying to move people away and get them away from the pathway of the mother and the calf. Yes, Betty?
So, Tim, what way are you capturing the sociological capsule around what you're seeing, like you're talking about now?
Go ahead, David, let me, okay, what Betty's asked for the recording is that how are we going about capturing these, what would be sociological, if you will, impacts on these animals?
Okay, there's, in Puget Sound, in the Sally Sea, there are several groups affiliated with the universities and NOAA, and they're actually able now to measure a lot of behavioral changes as a result of the increasing overall soundscape from anthropogenic or human sound in the water. Another case is a blue whale down in the southern oceans, down around Antarctica. one of the group that we've looked at or been with has measured that over the last decade, the sounds that the blue whale make, which are very low frequency, almost infrasound, but travel clear across the Pacific because their mates may be 2,000 or 3,000 miles away. They've changed the frequency. They've actually changed the pitch of their songs as a result of the impact of these propulsion systems that are becoming prevalent. So there's a global effort to do exactly what you're asking about. Our holy grail is to get somebody that can measure in microseconds what we see acoustically with what they're visually spotting. We haven't been able to do that. It's frustrating to us because we work in milli microseconds studying this, and most observers work in seconds or minutes. So if we can get that all munched together, I think we'll see a lot more productive results. Yes?
Yeah, the question was, how does ferry noise compare to the cruise ship?
Well, it's less. The newer class ferries, there's actually a group here on Bainbridge called Gloston and Associates, and they have specialized for decades in quieting vessels, and they have designed a system for the ferries that will be built, not the class that's the jumbo now. They're paying a lot of attention to marine mammals because they go right across where these things go. The ferry crews are well trained to slow down, stop, or avoid them by moving the tiller, to keep away from them. But the whale watchers, I mean, they make their living studying the whales, but most of them are very responsible, and they'll be the first ones to report, things like these kids on skidoos coming right up to the whales. But you can go out any day around a pod of orcas and you'll see over 50% of anybody on the water with a motor or an engine on a boat violating these distance rules. It's not, our education system has not caught up with reality yet. So that's my answer.
Yes.
I'm curious about communication patterns when you're talking about microseconds and clicks. Are you able to point to call and response patterns, especially between species, or is it more trains and streams that seems to overlap?
Yeah, the question had to do with looking at possible communication patterns within these very short timing clicks, and how are we evaluating that, and what do we see? And essentially, what we're looking at this level right now is we see a click, and then we see another click that just might be a few microseconds away, and then we see a series of that, and we see the peak frequencies changing between each click, okay? And when we look at that, it looks a lot like, is there some kind of coding going on? Because it's going so fast, is there some kind of coding that we're doing? And we're working with the French team right now with regards to a more sophisticated way to analyze this. David mentioned AI. They're starting to do that. The tools that we have now in MATLAB, we can see this, but it's really hard to get in and say what exactly is going on. We need thousands and thousands of samples and then start to look at this, and that's what that AI is going to do for us.
I'm curious, in looking at these samples and seeing multiple clicks, whether your equipment is allowing you to identify that the first click came from bearing A and the second click came from bearing B. That was the array.
Yeah, really good, excellent. Okay, you saw that hydrophone array? And that is designed to do just that, in that we've got 2 or 3 points, and we can say, okay, we first heard this particular click on hydrophone A, and then a little bit later, we heard it on B, and then a little later, we heard it on C, and just by doing the trigonometry of that, then you can determine the bearing to the animal. What we haven't been able to do yet is to figure out the loudness of the click, the distance of the way. We could do some crossing and things, but we really haven't been able to come out with a really good way to figure out range.
The Professor Glotton Hervey actually has done a lot of work with sperm whales over the years, and they have large heads. And he has figured out and written many papers on knowing where the whale is in 3 dimensions because the sound of there are 2 sound organs that make clicks. And these guys go down and chase giant squid. That's their main food. Well, click A bounces off the melon in one geometric pattern, click B another one, and he's able actually to track the path of these whales going down up to several thousand meters to catch the squid, yeah.
Do you feel we're able to distinguish at this point between sounds that are made as sonar and sounds that are made as communication?
Yeah, the question being, can we distinguish sounds that, for instance, are used for echolocation, for, let's say, cruising along the bottom or finding a fish or something like that, versus those that are used possibly for communication?
My answer to you is we don't have the foggiest idea, but there's no reason why they can't do both together at the same time. I mean, use the click for multiple purposes. The coding in the click could be the communication component, and the click energy itself. And we do see echoes. I mean, we see echoes from their prey, we see echoes from the bottom and the surface and all kinds of places.
Yeah, on the orca-whiteside interaction, what we were seeing with those clicks was definitely an echolocation. Those guys were clicking at an extremely high rate on a very, very narrow frequency, and so that they could be picking up the edge of a fluke or the side of the animal or whatever. So that was an echolocation, but we don't know, and we really haven't looked and don't have, at this point, the capability to say, gee, is there an interclick between this Pacific whiteside over here and this one over here? And we haven't been able to do that yet.
Well, an even crazier idea within a group or a pod, and I've actually been diving in pods of over 1,000 dolphins at a time.
Spinners?
Are they able to use the sound generated by animal being for echolocation?
This is polystatic. I believe they do. If you got 6 animals putting energy into the water, can animal B interpret what animal A clicks are seeing? And I think that it's pretty common sense that they can do that. How the heck do these spinners of hundreds of animals keep from banging into each other? You know, I mean, I think it's a 3-dimensional thing to them, just like our vision is.
Jim, you may want to mention that your vision for the citizen science project is rather than using a monolithic array of hydrophones, you have a distributed, right?
Yeah, and yes, on the project, we envision people will build their own system. They'll start by building a hydrophone with a cable on it, and we've essentially started that. They'll have some electronics in a box, and that'll go up, and we're looking at, gee, why not? We can have 2 hydrophones hanging on this, or we can have a system here and a system here that's recording at the same time. Now, one of the issues you run into when you have independent systems is trying to ensure that you can time sync those recordings. And that's the Norwegians are driving us nuts. I mean, those guys are out there swimming around in the humpbacks and the orcas and doing all this stuff and having this grand time, and they're turning things on and off. I mean, nobody's ever seen this kind of thing, so we cut them a little slack. But we've certainly told them a number of times, guys, sync these recordings with these videos. So
Even the Frenchman.
Yeah,
Hervey's terrible about this. He's a physicist, and he doesn't understand. You got to measure in picoseconds. So I think
Yes.
So conceivably, once you have this mesh array that, like, I feel like a good metaphor is weather systems, just homebrew systems that sort of communicate with each other and give you really accurate pictures of entire microclimates. So it feels like conceivably the next step would be to not use recordings at all, to just get a live data map of it, which is all streamed anyway, it's all Wi-Fi, tie that to the Orca watch, visually explode it, right?
The real, and it's a great idea, but streaming over Wi-Fi, that really broadband signal isn't going to work. We just, you just can't.
well, the technology may be there in the next couple of years, though. I
Well,
think you're right. I think it'll happen. We just can't do it affordably now. And Jim and I mean, we started to say, it cost you can buy a Tesla for the amount of money that universities pay for these arrays. We want to do it, it's affordable for individuals. And we're starting to do that. I mean, the little hydrophone, the active part of that is how much money?
We got 2 of them for $21. Okay.
So, and then you've got boards shrunk, these all kinds of little tiny circuit boards that used to fill up this room with the same amount of capability.
And the electronics, we talked, if you say electronics in a box, this is really an embedded system. And we're looking at a Raspberry Pi, and if they ever start selling them again, we, for $41, we can get a Raspberry and put that in it with a couple of other things, and we're ready to go.
We'll use solar power to keep a battery charged.
Yeah.
Just hang it on the float.
Can you talk about the bit rate that would be necessary in terms of how much data you're capturing?
We're going for 24-bit.
Okay.
Okay, Hervé right now, what, Hervé's doing 36?
32.
32, okay, but
But 24 is plenty.
24 we can do, and we're gonna,
That's a half.
What about the data rate transmit?
Wi-Fi. We're limited right now, the data, whatever we can transfer, it's gotta go over Wi-Fi.
Our sample rate, we hope, will be about 300 kilohertz. So we're generating a 24-bit word or 300,000 times a second. So there's a lot of data, and we'll put a buffer in this little box, which we could do now. But
Yeah.
eventually we'll have to pump it out using
and-
Wi-Fi.
And we would envision that the people that had this, they would be listening over a Bluetooth on a headset or a speaker, and they might be out and they got information that the orcas were coming, and oh God, here they are. And so they would push a button on this little GUI they had on their laptop, and it would start the system recording. And it might record for 30 seconds or something like that, stop, and then hit it again. And we can only jam so much storage into that, but, and as time goes on, we'll be able to, right now, I think we might be thinking a terabyte or so in that box that we could store it to.
Well, we're just scratching the surface. And if anything if you,
That's what the follow-on meetings are for, to kind of
Yep.
brainstorm.
right. But last week we got recordings from Tenerife of pilot whales. It's a 2-minute recording that we got. And Hervey sends us this stuff from all over the world all the time. There's probably 100 PhD theses in that 2-minute recording. That's how little we know about this stuff that begs for somebody to drill down on parts of it. So it's an exciting world for us. I tell my doctors, I said, I don't want anything else, but I want you to guarantee I'm going to live 10 more years after this visit. So,
Okay, so we will be sending out, everybody that signed up for this and came, we'll be sending out notice of the next meeting. And if you're interested, hey, show up. If you're interested in building, certainly, or just show up and give us some more ideas.
Would you recommend some other websites to look at, the links like OrcaNet and other things?
Dave, you have,
just go online and if you open Facebook and search, Orca just say Orca North Siley Sea. You'll see 3 or 4 of them. Orca Watch is all over the country. Actually, it's all over the world. But there are other groups that are specifically for the Siley Sea, and there, you'll see a list of them, and then they all have that you can connect to them.
Sir, yes.
Would it be possible to take these click sounds and connect to or sync with a type of sonar system that could produce a 3D image to sort of prove out the theory that one animal is putting out clicks that the whole group is using as part of their echolocation?
The question was, would it be possible to take one of these recordings that's got a series of clicks in it and play that back through a system to see if we could see if other animals would respond to it?
You just volunteered, Scott.
To see if like a sonar system, I don't know
Yeah.
what that sounds like, could interpret those clicks into a visual image like what we're using on ships today, for example.
Yeah, the French are doing some of this, and in Hervé, he's got all kinds of different things going on, and like Dave said, he's using some of the clicks from sperm whales, and they dive really deeply for these giant squid, and he's actually tracking them, and it's almost like a video game. And this comes down, and they're talking, and this animal goes down, and it's pinging out, and then they say, oh, there's a target, and you can see on the screen, here's the squid over here, and here comes the sperm whale like this, and then they're actually coming in it, and the positioning of the prey, the squid, is actually based on the return that they're getting on the acoustics. Okay, so they're doing that.
He actually asked us to take a look at multiple sperm whales going after these squid and prove that they're communicating with each other as they're doing that. And we could correlate animal B at a different depth than animal A going after these squid. And as this guy moved, this guy started moving with him. And so they've got the 3D vision with these, and they're the strongest, the loudest things that are made in the ocean that aren't man-made are the clicks from sperm whales. And so, they're doing what you're saying, but we don't know how to figure out how to mimic that yet. So.
Commercial opportunity for you to sell to surfers saying, I am predator, not prey.
No commercial opportunities here at all. I'm done. I'm retired.
So along those lines, the work that you're doing, is this covered as part of a company, or are you doing this on your own?
You are looking at 2 volunteers, retired volunteers.
We don't. Yes, very, very retired.
The software,
It's free.
you're bearing that on your own.
Yeah, and again, we've had some of this, okay? We've got some of these tools, some of these things are available. We were able to get this program, MATLAB, at a really good price. We found this other stuff that NASA did. We got that for free. We took that and we applied what they were doing to what we wanted to do. So far, we've spent a few dollars buying these little hydrophone crystals and these other things, and we'll build this prototype, and we'll probably have, I don't know, $100 into it, each of us maybe, by the time we get this whole system as a prototype built. And then we'll say, okay, what's it going to take to glue all that together and the timing, and then we'll go back to Doug over here and say, okay, I think we can do this whole series of sub-projects for X number of dollars.
And the barn's perfect. I mean, if we need a machine shop, we got one. Well, I know we're going to use 3D printers for some of the stuff we're looking at doing. I mean, I can't believe there's a better place in the United States than right where we're sitting today to do this kind of volunteer, citizen scientist work. So.
Where does the money come from?
My pocket and Dave's pocket.
Actually, my wife's
and again,
pocket.
we might have, by the end of the day, maybe $300 into this total, as far as putting this prototype together. And hey, just we don't count the hours. Yeah, we're retired. Okay, the hours don't count. Yeah. Yes.
Yeah.
Anything about sound in water, but is there any direct
all of the marine mammals have what we call a polar distribution of where the sound beams are that come out of their melons. And most of those animals have been mapped in a lab. Now, we don't know that they behave the same way without humans in a swimming pool, but they do have that. And our hydrophones actually aren't spherical. You can design one that's spherical, but the one that we want to use with these high frequencies probably is more of a toroid shape. And we're in the next couple of weeks, Jim and I are going to test that to see what these little things look like.
So essentially what this is, there's omnidirectional sound in that it's coming from everywhere, okay, and then there's focused sound, and the clicks, for instance, are focused. There's a very narrow beam pattern that they're focused on, and we can see that as the animal's going along, if they turn, the level coming into the hydrophone and sometimes the frequency will actually change, because instead of the intensity coming right at the hydrophone, now it's 20 degrees off to the side, and we're picking up maybe a little side lobe off that main pulse.
So I'm just mulling over everything that you guys are talking about. Very interesting. You know, the high frequency content of clicks is maybe not surprising, right? Because Fourier theory says that it has to have high frequency content to be a click burst. The question I would ask, though, is have anatomic studies been done of the species that have this presumed higher sensitivity and established that those sense organs, in fact, are sensitive to 100 kilohertz, 200 kilohertz, whatever it might be? Has that kind of
There's a gal in Woods Hole that has been doing a lot of that work. She specializes in marine mammals, but she's a physiologist, and especially with their sound making and sensing. I mean, one of the first questions I had is, how the hell does this animal process something that's on a microsecond basis? And it's parallel processing. I mean, that's what the hypothesis now is that their brain size is bigger than ours in many cases, and they don't just process that click in one part of their brain or a series of clicks. It's parallel processed with many neurons or whatever.
But is the sense organ resonating at those frequencies? Forget the neural process.
That's a good question. I mean, I got a question about are their teeth some sort of mechanical modulator? If you want to do a PhD on it, but you should, because nobody's done that.
When you say microseconds, is that the length of the pulse you're talking about?
Yeah.
So that pulse has energy that's spread out over a lot of frequencies. It's just the width of that pulse.
Yeah, the orcas are about 50 to 75 microseconds. Smaller marine mammals, the ones I study in the Amazon, no more than 30 microseconds per pulse. So they all vary.
You looked at mapping the patterns of the clicks in terms of spatiality and sort of like the silence between clicks. Like, do they all fall into any kind of pattern language, or are we just looking at like sequential clicks?
No, we haven't really looked at that.
People have looked. I mean, people are interclick interval, we call it. And is there a pattern within the interclick intervals? And a lot of people have looked at that. I don't know that anybody's come up with any. What I see is it goes from very clear patterns to anarchy. So I don't think there's a real answer yet.
You say there's AI software that can match an animal, no member of the pod to a signal, so it can have it reverse engineer that to what the characteristics are that are not important there.
The question had to do with what can we do now with the AI software, and I think it's so new now that that people are trying to do that I don't think we really understand its capabilities. I think as people get smarter about this and start looking at some of these different data sets, I think that it's going to open up a whole new world. We're really limited in the analysis. we're essentially doing the kind of analysis they've been doing for 15 years. Fast Fourier transforms, that kind of stuff, looking at this stuff. It's just, we've come up with different ways to use these tools to see different things within this. But AI is the next big step.
For anybody that knows this stuff, we're actually looking at other transforms that may be more appropriate for these kind of phenomena. The paper that I showed, we actually did a Fourier, but we also did what they call a Gabor transform. And they matched up pretty well, but the Gabor had slightly different emphasis on things that we didn't see in the Fourier transform. And all these transforms are just humans fiddling around with mathematics. And you know, who's the guy that wrote the code for that Fourier transform? You find out that guy A doesn't write the same code as guy B does for the same Fourier transform. So it goes on and on and on.
It is well after 1 o'clock, so if anybody needs to be anywhere, feel free to head out, and then you can still get these guys into a corner.
And again, hey, thank you, everybody. Appreciate it.
Yeah, thank
and
you.
especially those good questions.